Section 2, Similar Polygons. So two polygons are said to be similar, which we use this symbol for, if and only if the corresponding sides are in proportion and the corresponding angles are congruent. So when we were talking about congruent triangles, we said that the corresponding sides were congruent and the corresponding angles were congruent. For similar, the angles still have to be congruent, but now the sides are just in proportion. The ratio of the corresponding sides is called the ratio of similitude, or a scale factor, or the constant of proportionality. In this example, we can see that the scale factor is 1 to 3, depending on which way you're comparing the triangles. If it's small to big, it would be 1 to 3. If it's big to small, it would be 3 to 1. But even if we reduced 4.5 over 1.5, it would still give us 3 over 1, or 1.5 over 4.5 would still give us 1 over 3. Now the following properties hold true for similar polygons. The reflexive property, so you can write it as triangle ABC is similar to itself. Here the ratio of the lengths of the corresponding sides is a 1 to 1 because it's the same triangle. The symmetric property, so if triangle ABC is similar to triangle DEF, then triangle DEF is similar to triangle ABC, so you can write it either way. And the transitive property, if triangle ABC is similar to triangle DEF, and triangle DEF is similar to triangle RST, then triangle ABC is similar to triangle RST. If two polygons are similar, we know that the ratio of their corresponding sides, altitudes, perimeters, medians, diagonals, and angle bisectors are all in the same ratio. So if we have two triangles and we're told that they're similar, and let's say they're in the ratio 1 to 2, that means their altitudes are also in the ratio of 1 to 2. Their angle bisectors are in that ratio. Their perimeters will be in that ratio. They're all going to be in the same ratio. So if this is 1, 2, 2, so we have an isosceles triangle, and they're in a 1 to 2 ratio, so this will be 2, 4, 4. The perimeter of the first is going to be 5. The perimeter of the second is going to be 10. This was the same thing as a 1 to 2 ratio, if you reduce it down. If two polygons are similar, the ratio of their areas is equal to the square of the ratio of their corresponding sides. So if the corresponding sides are in the ratio of 3 to 4, you square each of those, so the areas are in the ratio of 9 to 16. And finally, if two polygons are similar, the ratio of their volume is equal to the cube of the ratio of their corresponding sides. So if the corresponding sides are in the ratio of 1 to 3, you cube each of those numbers, so the volumes are in the ratio of 1 to 27, which makes sense because areas are square units, volume is cubed units. So you do the same thing to the ratios. But here, this is important. If the polygons are similar, the ratio of the corresponding sides is the same thing as all of these ratios between the two polygons.